Hello, I'm here today to talk to you. My name is Jesse Kanter, and I'm here today to talk to you about my project checkVid that I did at Insight, helping parents to screen YouTube videos quickly. And the motivation behind this is that my son will often ask me if he can watch a new video on YouTube, and I had to choose between screening the videos to make sure they're okay, or just telling him no because I didn't want to take the time. And the reason I have to do that is because there are good and bad videos. So for example, there's Elmo's World talking about birthdays, which I know is perfectly fine. And then there's Elmo's World behind the scenes, where Elmo's a little more colorful and not suitable for children. So this isn't just a problem that I faced, but other parents have as well, and YouTube itself has tried to address it. The problem is YouTube has always one of two approaches. Either they set up an algorithm that takes in all of the videos, let's say the bad ones are the ones in red here, and tries to read out the bad ones. However, a few will always make it through because you have imperfect algorithms. The other option is to assign people to pick out the bad videos. And people are actually very good at that. However, there's way too many videos for them to handle and not enough people. So what I did is I created a Chrome extension that lives in the space in between these two by creating a quick report for parents to look at so they could decide what's a bad video that they want to shoo away and a good video that they want to keep for their kids, putting the parents in control. In terms of how I did this, the data I got was YouTube transcripts. These are a bit of text of what was spoken per second or two, so you have a pretty good idea of what was spoken when. And then a list of words I want to avoid. For the example here, I'll focus on profanity. Once I have a given text, I assign a score for every word in that text, and that bit of text gets assigned the maximum score because, again, we want to point out the most problematic thing for parents to see and know if it's a problem. There are two ways that I went about doing the scoring. One is a dictionary approach, where I just tried to see if my bad words were present in the text, and that does most of the heavy lifting. However, in case there's words I missed, this is supported by a Word2Vec model, where the model sort of assigns words a position in space and groups similar words together. I used the pre-trained Google News vectors model for this. That was trained on several news articles. And so it'll catch the word moron, for example, if I miss that because it's close to another word there that I won't say out loud. This is a good approach. However, it does miss out on context because it's just looking at single words by themselves. So I also took the approach of a BERT model. I translated the sentences into BERT vectors and used cosine similarity to see if they were similar to bad sentences. What I found was that the BERT model didn't work very well. It kind of marked everything as similar, which was problematic. However, the dictionary and Word2Vec worked fine, and even though there was that context issue, since in the end of the day it's going to rely on the parents deciding what was good or not, and parents have that human touch to it, they can quickly see if something is out of context and move past it. So for the product sense, this approach was great. In order to validate how well the model was doing, I tested it on this toxic comment classification challenge. This is a Kaggle data set, but it's actually editorial comments on Wikipedia that were marked by people as obscene or not. And I found that obscenity was a pretty good proxy for profanity. And so I ran my model, and using a threshold of 0.6 as a score to mark something as yes, obscene or not, one could see that the amount of times I predicted something as not obscene and it actually was obscene is fairly low compared to everything else. And this is actually good because what I'm most worried about is I don't want to mark something as fine if it's actually problematic. I want parents to know when something is a problem. And if we lean a little more heavily on that's the false negatives we want to avoid. If we lean a little more heavily on the false positive, the predicted as obscene but turns out not, that comes back to that context issue, and it's okay because at the product end, a parent will be able to see if something is not a problem. With that, I'm going to move over to my demo. So we go over here to YouTube, and this is that Elmo's World behind the scenes video I mentioned. And I'm going to click on the Chrome extension up here. It'll ask me if I want to get a report. I'll say yes. And you see the first line here, the word piss is used, then another word I won't mention out loud. And so parents could tell pretty quickly that this is not the video they want to show for their children. This was hosted on EC2 instance on AWS. Okay, that's it for the presentation. Again, I'm Jesse. I did my physics PhD research at CUNY. I got my PhD from the Graduate Center and did the research at City College. It was experimental physics research, and the basic idea was, yeah, I spent half of my time doing experimental measurements in the lab, collecting data, and the other half of the time analyzing that data using visualizations to weed out different physical signals that were present in the data itself. Those were all great analytical skills that I'd like to now take to data science, because I'd like to move into a more product-driven industry where I'll see more actionable insights from my work. And a fun fact about me is that in my own time, I like to make my own bread, including challah, bagels, and babka. Thank you, and I look forward to hearing from you.